Hello friends, how are you? After finishing our first lesson in class 9th, I am starting second. That is matter around us pure? Okay, I hope you understand the first lesson and also complete the work. But there are less submission of the assessment assignments. So please do complete the work regularly and submit in the app. Okay. Now, let's start. First thing that's come in our mind, that is what is matter. As we discussed in the previous chapter about the definition of matter, I am repeating here because this chapter is totally related with the matter, its properties, types of matter, and how can we make a matter pure and something like that. Okay, so I'm starting about matter again. What is matter? Any substance which has mass and occupies space. Any substance which has mass and occupies space is called matter. As we discussed in the previous class, previous chapter, should have mass and should occupy any space. These are the two basic properties of matter. Now, types of matter, the classification of matter we also discussed in the first chapter, but I am repeating here again because all of these we will discuss in this chapter. On the basis of the states, matter is classified into three categories. One is solid, second is liquid, and third one is gas. About these three we already discussed in the chapter first, so I am not repeating here. On the basis of the composition, the matter is grouped into two categories. One is called pure substance and another is mixture. First thing is pure. Any substance which made up by only one type of particles. Made up by only one type of particles. That means single type of particle is constituted, then it is called pure substance. But if it is made up by two or more type of particle, it is made up by two or more type of particles, then it is called mixture, or we can say two. If there is presence of the two or more type of particle, then it is called mixture. Pure substance is further divided into two categories. One is called element, one is called compound. Element, that means the constituting particles, the atoms are same, like the H2, O2, H2, that means both are hydrogen hydrogen, O2, that means both are oxygen oxygen. That is called element. And one, if the pure substance is made up by two or more type of atom, I am using here atom, like H2O, CO2. Here H2O, one is hydrogen, second is oxygen. CO2, one is carbon, another is oxygen. These type of compound come in the category of these type of substances come in the category of compound. Okay. Mixture is further divided into two categories. One is homogeneous, second is heterogeneous. If the mixture is uniform, if the mixture is uniform, then it is called homogeneous. Uniform means, that means there is no separation boundary between the component, like the sugar and water. After dissolving the sugar, you cannot you cannot identify that where is sugar and where is water. Okay. Heterogeneous, when they mix, the component of mixture are make non-uniform, are non-uniform, that means there is a separation of boundary. Okay, like the sand and water. After the how many after the mixing of the sand in the water, you can easily identify that where is the sand and where is the water. The heterogeneous mixtures grouped into again two categories. One is called suspension, one is called colloidal suspension, that is sand and water, and colloidal, that is milk, smoke, clouds, etc. We will discuss about in the next classes. Okay. Now I am starting about the mixture. What is mixture? As we discussed above, the matter which is made up by two or more type of particles. The matter which is made up by two or more type of particles is called mixture. Or we can say the substance which constituted or made up by two or more kind of pure matter is called mixture. For example, cold drinks, air, sugar solution, etc. I am taking example of sugar solution to give the difference between the pure substance and mixture. In sugar solution, one is sugar and other one is water. If I consider them separately, then both sugar and water are pure substances, because in sugar all the crystals are made up by same type of particles. Okay, and if I consider water, that is also pure, because all the component or all the particles are similar, that is H2O H2O. Okay, so these sugar, water separately are pure substances, but when they mixed, then the formed sugar solutions comes in the category of mixture. Okay, now let me move the types of mixture. On the basis of the nature of the component, there are two type of mixture. One is called homogeneous mixture and other is called heterogeneous mixture. Okay, homogeneous mixture is also called solution. It is also called solution. Okay, now the definition of it: if all the components of mixture are are uniformly mixed and there is no boundary of separation between them, then this is called homogeneous mixture. Example, salt solution, or as we discussed, sugar solution. They comes in the category of homogeneous mixture. Now let me move to the second one, that is heterogeneous mixture. If all the components of a mixture are not truly mixed, that means they are non-uniformly mixed or not truly mixed, and there is visible boundary of separation between them, then it is called heterogeneous mixture. For example, sand and water, clouds, smoke, petrol or oil plus water. Clear? Heterogeneous mixtures again classified into two types, that is suspension or colloidal. So if I am combine all of them, then I can say mixtures are grouped into three categories. One is solution, which was homogeneous mixture. Second is suspension. Third one is colloidal. Okay, so these three are the types of mixture. I am starting one by one. Let me discuss about the solution. What is solution? The homogeneous mixture of two or more substances. The homogeneous mixture of two or more substances which are uniformly mixed, is called solution. Okay, the properties of solution is remain same throughout the entire solution. The properties of solution is remain same throughout the entire of solution. Suppose you have a glass of water and you added some sugar. After dissolving the sugar, if you taste the water from the bottom side or from the upper side or from the middle, you can taste the sugar in all of these parts. Is there any different character you appear that? No. All the in this example we are taking the sweetness as a character. The sweetness is remain same in throughout all the solution. Okay, so we can say the property or character is remain same throughout the entire solution. Now, components of solution. Solution has two components. One is called solute, other is called solvent. One is solute and other is solvent. One is solute, second one is solvent. Now the questions comes in our mind, what is solute and what is solvent? Solute, the component of solution that is dissolved, that is dissolved is called solute, while the component that dissolve the other is called solvent. The component which dissolved or disappear is called solute, while the other one which dissolves the other is called solvent. For example, in sugar and water, sugar is solute and water is solvent. Okay, now how can we identify that which is solute and which is solvent? Very, if you observe very lightly, then you can also, if you goes deeper then you can, but if you lightly observe then you can also identify which is solute and which is solvent. The substance which is less in quantity is solute, and the substance which is more in quantity is solvent. Okay, secondly, the substance which disappear is solute, and the substance which remain visible is called solvent. In sugar and water, in solution, there is a 1 glass of sugar, 1 glass of water, and 1 teaspoon is of sugar. So which is less? Sugar. So it is solute. Okay, and after the dissolving, which is disappeared, that is sugar. So that is solute. So by generalize these two properties, you can identify which is sugar, which is solute, and which is solvent. I am considering some example of it. One is salt and water. So salt is solute, water is solvent. Second example is tincture iodine, which is we use to clean the any wound or any cutted part. We put some liquid in on it, in which iodine is solute and alcohol, that is solvent. If we considering the example of cold drinks, then cold drinks, I am here considering about the soda water, not the cold drinks, the Pepsi, Thumbs Up, I am not considering here. I am considering about the soda water. The carbon dioxide gas, which is solute, and water is solvent. Okay, clear? Now let me discuss about the properties of solution. What are the properties of solution? Properties of solution. First property, the solution is homogeneous mixture. That means there is no separation boundary between the components, or it is same entirely or throughout the solution. Clear? Second, the particle size is very small. It is less than 1 nanometer, nm. 1 nanometer. 1 nanometer is approximately 10 to the power minus 9 meter. It is very less for our eyes. We cannot see that. We cannot see such small size particles. That's why, so they cannot be seen by naked eye. Without instrument, we cannot see the components of solution. Clear? Now, third point, due to smaller size, they do not scatter a beam of light. So the path of light is not visible in a solution. If you ever observe that during the winter season, when the light comes in our room through a small hole, then the dust particles and the path of light is visible to us. Have you ever seen? Memorize it? Yes, that is the example. In that case, the dust particle scatter the light, scatter the light, and because of that scattering, the path of light is visible to us, and the dust particles also visible to us. But here, due to very small size, there is no scattering. So if a light is passed through a solution, then there is no path of light is visible to us. Okay. Fourth, solution is a stable substance. That means we they two or three things that we can discuss in that point. First one, if the particle, if it is lefted undisturbed, that means for example, there is a glass and I put it here for 2 hour, 3 hour, 4 hour, or 2 days, 3 days, 4 days, then its component do not settle down. It is not possible that sugar, after the 2 hour, the sugar settle down and collectively appear in the bottom side of the glass. Okay, so its particle do not settle down when left undisturbed. That is the first point of stability. Second, the solute particles cannot be separated by filtration. By filtration, like for example, like in the case of tea, when we filter out, then the bigger particles of tea leaves remain on the above portion while the liquid part separately. It is not possible with the solution. If you filter out the sugar solution or salt solution, then it is not possible that sugar or salt remain in the above portion of the filter paper and the water remains separate. No, both passed out the filter paper. That means they cannot separate by filtration, because that 2 points are its stability. Okay. Now next point is concentration of solution. What is concentration? The amount of solute present in given amount of solution is called concentration. The amount of solute, that means 2 gram, 3 gram present in the given amount of solution, that means 10 grams water, 15 gram water, that is called concentration. Or we can say the amount of solute dissolved in given mass or given volume, that means 2 gram water or 2 liter water. 1 teaspoon sugar, that is solute. Amount of sugar, that is 1 teaspoon, yet 2 gram, that is amount of solute. And in given mass, that is 100 gram water or 1 liter water, that is its mass or volume of solvent, is called concentration. So if we make a formula, then the concentration of solution is amount of solute divided by amount of solution. Or if we are using this definition, then we can say amount of solute divided by amount of solvent. There are various methods of representation of concentration of a solution. Here, two methods in our syllabus. One is mass by mass percentage, and second one is mass by volume percentage of solution. In the mass by mass percentage, the mass of solute divided by mass of solution and multiplied by 100 to convert into concentration, percentage concentration. While in the case of the volume, mass by volume percentage of solution, the mass of solute divided by volume of solution and multiplied by 100. Okay, there is one example so you can understand it very clearly. A solution contains 40 gram of the common salt in 320 gram of water. A solution contains 40 gram of common salt in 320 gram of water. Now calculate its concentration. Since it is mass and that is also mass, so the formula will be that one, mass of solute divided by mass of solution. Mass of solute is 40 gram, mass of solvent is 320 gram, but there is no mass of solution, as we know that solution is made up by the solute and solvent. So by combining them, that means mass of solute plus mass of solvent, we can find the mass of solution. Here 40 plus 320, that is 360 gram. So that is the mass of solution. Okay, now As you know, the formula is mass of solute divided by mass of solution multiplied by 100. So when we put 40 divided by 360 and multiplied by 100, then the answer is 11.1. So one thing, let me clear you again. If there you have to, if there is given the mass of solute and mass of solvent, then you find the mass of solution. But in some questions the mass of solution is already given. So if it is given, then directly put, and if there is a given the mass of solute and mass of solvent, then add them and find the mass of solution. Okay, hope you like it. Thank you, and please submit the homework properly. Okay, so we can check that how much work you are doing and how much care you are doing about your classes. Thank you.